this is Jake Roden for Engineering Technology 196, going over the different advanced workbenches in CATIA 3D Experience. This is the static study workbench, doing kind of physics studies and making sure your part can withstand whatever stresses it may be going through everything. So this is the base part of my student project. This is what would be going through the most stress, so I thought it would make the most sense to test it. Now we can see here, obviously we have a bunch of bent sheet metal, and we have not affixed it yet, but right here we have this point meeting this point. They're not affixed, they're not welded or anything. Realistically, they probably would be. But I wanted to see, maybe depending on the kind of weight being applied and everything, let's see how much would that bend, how much would that deform, and maybe depending on how much it deforms, maybe we don't need to weld it. Maybe we can actually save ourselves some time and money with this study. So over here we have the assistant all set up. This will just help you walk through everything. So obviously we already have our material applied. This is stainless steel. Boundary conditions for this, we're going to say that kind of this inside part right here is going to be clamped, because that'll stop that from deforming, hopefully, and we'll say that's where it's being carried, so maybe somebody's carrying it, and all those tools have weight in them, they'll kind of get moved down. So obviously now that we've applied a boundary condition, we got our little green check right there. Next we're going to add in our loads. So for this, let's see how we can do this. If our tools are all sitting on the inside of these, can I apply a force? Maybe ready to do pressure. What's being added extra? Let's see. Remote torque gravity. Okay. Might just not let me select it here. Oh, there we go. Then we want to make sure it's kind of in the straight down direction. I'll try to hit it with global axis system. There we go. Then we want to put that right in the Z direction. So it should be the way that we want it. And then we'll say, I'm not sure what the exact weight to newtons, but we can say maybe we have some kind of, 5 pound. We should be able to put pounds in here, right? 5 pound tool. I think it was cap locked. 5 LB, because that doesn't measure force. Or not. In that case, we'll just put 100 newtons. Come on. Going down. Can we align global and then rotate about Y 180? There we go. That's what we were looking for. Sorry about that. So we can see now that this force is being applied straight down. Hopefully this will be able to show us, and we can be able to see as this kind of gets brought down, maybe how much this would be deforming and everything. We can see that it's saying that we do have a load applied, and you would probably realistically put loads here, 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 and here. And we'll simulate it. And this can take a while, depending on your hardware and kind of the complexity of your simulation that you're running. And now we can see, obviously, let's press close, but it does appear that we do want to add some welds to that, just because you can see how much it's deformed. If that handle is straight up and down, we can see all that movement down in there. We can also see looking at our von Mises stress, how much stress is being formed kind of right there at those points on the handle. There's a lot of stress down here on this circle over on this side. We can see all that stress getting formed around it. That would definitely be some kind of maybe point of failure. We can see some stress getting formed down here on this kind of edge, this radius right down here. Not much stress over on this side though. You can also see our displacement. We can see that obviously all the brighter areas are being moved more, so we can see this is moved a lot from its original kind of location right up here, and this all has moved a little bit, and this hasn't moved very much at all. You can also see factor of safety, you know, where kind of things are getting unsafe. So obviously this would be getting unsafe. Reaction force factor, so this is showing based on your boundary condition the kind of reaction forces happening. You can see all the little vectors popping off in their different directions. And we also have compression and tension, which we can see all over this thing. So obviously we would want to add a little weld to that, and then we could add a weld to that and see, okay, maybe it's taking the force a little bit better, maybe it's not taking the force as well. Maybe we need a stronger weld, maybe we need to rethink the kind of design that we're going for. Maybe we want to add the break at different points. Maybe you wanted to have it so that it's actually two pieces of sheet metal that are being welded up here as the handle, and then kind of coming down in like a Y shape with a break down here in between them. Or maybe, you know, with the weight of the tools you're carrying, you need to make this sheet metal thicker. This is only 1/8 inch. Maybe you need to make it thicker so that you can actually carry heavier tools and all that stuff. You can also see, if we go over to results, we can play the animation. Let's slow it down so we can kind of see, and we can see there all that stress getting generated and all that stuff getting pulled down. We can also just go back to loads, and probably we should be able to just apply more and just really watch as it kind of stresses and deforms. Let's move this out of the way, align this globally, and then let's align. Can you just rotate this? It's not going to let me rotate it very well. Rotate it about X, it looks like 180. And we'll say that that's, you know, also not 1200, be a lot, also 100 newtons. And we can see now that we have equal forces on both sides, we have one tool in each of those top ones. Maybe our results are going to show up a lot different. So let's simulate with this kind of new load applied and see how much different it might look. Because maybe, you know, maybe it's evening out a little bit. Maybe it's actually going to be bending a lot more stress maybe. So our simulation is complete. We go to our results and we can see, well, looks like obviously this is getting a lot brighter. It looks like there's going to be a lot more stress down here. Displacement looks like it might be about the same, maybe even a little bigger. Maybe. You can go to von Mises stress and kind of watch as all of that stretches and all that kind of stress gets applied. And let's see what it looks like with all four of them. Force, select this inside of the circle. I have to zoom in a little bit to get it. There we go. Align that globally, rotate it over Y, make that 100. Do the same thing over here, and with another force applied on this side, it's probably going to be bending pretty seriously. Oh, wait. Let's make sure we actually apply a force to that. And now let's simulate. This might take a little bit longer. Just with all the different forces we have acting on it. And press close. Let's open up our results. And we can see it does look like a little bit more stress maybe. Still not much stress over on this side, but a lot of stress on this hole and everything. It looks like it might actually be a little bit better. Obviously there's still a lot of red around this side, but it looks like there's a little bit less stress on this side. Maybe it kind of evened it out. You can see our displacement, obviously a lot more displacement with that second one down on this side, pulling it down and everything. See our factor of safety, not looking very good over on this side now that it's getting so much stress put on it. Looks very, very unsafe. Compression tension, we can see all of that on the inside. And then we also see our, like I said, our displacement, which is really, really high for this bottom corner, because it's getting, you can get a good side view pulled down so far. So yeah, obviously we would want to weld this, then we'd go back through and check it again, and then keep going, keep iterating until you get something you want, or if maybe you have to go back to the drawing board and rethink kind of your part and how it works. Thank you for watching. This has been a static study. Have a great day.